All right, guys, welcome back. And today we have a full lesson. We're going to talk about solving one-step equations. This is going to be a little bit more than what I did in my classroom, and probably a little bit more than what your teacher gave you in the classroom as we ended the eighth grade year. Because we're going to be introducing different steps that's going to lead us into our algebra and the way we're going to use these equations to solve our algebraic problems. But let's get into it. I'm not going to talk about that. An equation. Let's go through this really quick. These are all non-examples of equations. All right. These are basically expression. This one right here is what you call an inequality because it has that greater than sign. These are expressions on this right side over here. These are all equations. What makes them equations? Because they have an equal sign. If you would take 3x minus 12 and put an equal sign there, plus equal sign to 2 plus 3, then that would be an equation. But these by itself without an equal sign are simply expressions. All right. So an equation is basically in two expressions that are equal. You'll see it expressed as this, and we just said that. I'm skipping through this because these are basic things, basic principles. We know that over here on this right side that this is not an equation, or it's set up as an equation, but they don't equate because 2 plus 3 equals 5. That's not true. Okay? They're not boundless. All right. So what does it mean to solve an equation? It basically is this, and you can jot this definition down and you can keep it pushing. You're solving an equation. When solving equations, you'll find the value that makes the equation true. This value is generally represented by a letter, which we call a variable. Okay, you see the star minus 14, the blank over 7. Those, let's see, that's basically what's being said in these other boxes. In one-step equations, a variable is a symbol, usually a letter, that's what I just said, that represents a number. It is what we are trying to find. We are going to find it or solve it by using inverse operations to isolate the variable. Basically, to get the variable on. That's the goal, is to get the variable by itself. How are we going to do that? Inverse operations. What is our goal? To get the variable alone. How are we going to do it? Using inverse operations. What is our goal? Get the variable by itself. How are we going to do it? Using inverse operations. I just told you what we're going to do and how we're going to do it. That's what this lesson is about. Let's keep it moving. Inverse operations, additive inverse operations, that's basically addition and subtraction. Basically, it needs to add up to give you 0. What is the additive inverse of 3? The answer is negative 3. How is that so, Mr. George? 3 plus a negative 3 gives you 0. Boom, there we go. All right, moving on. What is the additive inverse of negative 5? Positive 5, I hope you said it. Why? Negative 5 plus 5 gives you 0. You're doing real good. Multiplicative inverses. They basically multiply to become 1. Let me say it again. Multiplicative inverses multiply together to become 1. Here's another vocabulary word that we introduced in the last 2 lessons. They are reciprocals of each other. Now let's look at what that means. What is the multiplicative inverse of 3/4? The answer to that question is 4/3. Why so? Because they multiply together to give you 1. All right? Take some time, jot this down, process what I just said because that's going to be vital as we proceed. Okay? What is the multiplicative inverse of 2? Remember, 2 can be expressed as the fraction 2 over 1. Therefore, the multiplicative inverse, whenever we need to cancel out the whole number 2, we cancel it out by multiplying by 1/2. Now, here's the critical part that you got to get and you got to understand. If didn't nobody tell you this, Mr. George is telling you this right now. A fraction is also a division problem. You can divide the numerator by the denominator and simplify it that way. And that's basically what it's saying right here. 2 divided by 2 gives you 1. Okay? Add that to your notes. I'm moving on in 3, 2, I tricked you. I didn't say 1. I hope you don't got no questions. If you do, jot your questions down. If you got a question, jot it down right now and ask me via Google Meets. All right? If you have a question and you're not in my classroom, you can type that question down in your comments here on the YouTube video and we can keep it pushing. All right, so review of inverse. So this is basically reviewing inverses. How do we get rid of that positive 12. This is a thumbs up, thumbs down. I'm not doing that because this is a one-on-one YouTube video and I can't see your thumbs. But the inverse of positive 8, what is it? Also, I'm trying to keep the length of this video down. It is negative 8. Okay? We cancel that out by negative 8. I'm moving through this fast. How are we going to get rid of this minus 3? The answer is going to be adding 3. That's going to cancel out the minus 3. How are we going to get rid of this 2 in front of the x? Because we're trying to isolate the variable. Remember, we just had that. We're going to multiply by 1/2. Okay? Not by negative 2. 1/2. Negative 2 times 2 is negative 4. Okay? 2 times 1/2 is 1. All right? Let's keep it moving. 1/5. How are you going to cancel out that 1/5? You're going to multiply by 5/1. That's going to make that 1/5 1. All right? Let's keep it moving. Let's see. I'm going to keep it moving because I want to get to some of these examples. I may have to chop this up into 2 different pieces. All right, so now it's time to practice, all right? Let's practice. All right, so this is saying x minus 4 equals 28. We're going to do, that's an additive component. The opposite or the inverse of minus 4 is a plus 4. So we're going to be adding 4 to both sides. That's a yellow line that crosses out. That gives you a 0 pair. And we're left with 28 plus 4 gives you 32. That means x is 32. This slide is telling you that you can check that by plugging 32 in for x and subtracting 4, and it gives you 28. 28 equals 28. The equation is true. What do we want to do here, guys? Well, we have a plus 8. The only way to get rid of a plus 8 is adding a negative 8 to that. Adding a negative 8 to it cancels that 8 out, gives you a 0 pair. Then you have 43 plus a negative 8, or 43 minus 8, and that gives you 35. Therefore, 35 is what x is. Once again, you can check that solution here. All right, here we go. Here we go. Here we go. We got the fractions. Oh, no. No problem. Remember what we said we're going to do. We're going to use a multiplicative inverse concept, all right? What is the inverse of 2/3? It is 3/2. And you see that it illustrated over here. 3/2 times 2/3 is going to give you 1. So you're going to multiply 3/2 on both sides. When you multiply by 3/2 on both sides, what happens is this side cancels out. Is it going to show it to me? It didn't show it to me. It didn't show me the canceling out. You end up with 6/6, which is going to reduce to 1. On this other side, 12 times 3 gives you 36. 36/2 is my answer, right? Well, we still got to simplify this 36/2. Remember, I told you guys that a fraction is a division problem. So 36 divided by 2 gives you 18. Let me pause for a moment and say this. Right now, I don't mind if you guys use calculators to assist you with the math. What you need to really focus on is understand the process. Understand why we're doing it, why we're doing what we're doing. That's what's key. If you don't understand the process, that's what you need to ask questions about. If you're stuck on calculations, use your calculator to assist you. That's why we're giving you calculators, because it's all about the process now. All right? Keeping it moving. This is a check of the solution. All right, here we go. What are we going to do? What are we going to do? What are we going to do? What is the inverse of 4? The inverse of 4 is 1/4. Okay? You see this illustrated over here. Okay? You can always look to this side and you'll see what's happening. 4 times 1/4 gives you 1. Okay? But you got to multiply by 1/4 on both sides. As you can see, this cancels out. You're left with 1x equals a negative 28/4. Remember, this is a division problem. 28 divided by 4 gives you 7. Therefore, x is a negative 7. I'm going to skip through the solution, to check the solution that it gives you. So listen, here's the thing about it, guys. Really make sure you understand the process and the steps that I highlighted here in this video. I went through it rather fast again because I'm trying to keep the time limit under a certain frame because YouTube will delete the video if I don't. But the process, the thought process, the steps here are critical so that when we progress in our algebra, we can solve these problems that you see here. But if you don't understand what's happening now and here, then when we get to these steps in algebra, you're going to be really, really lost. This is vital, guys. Make sure you understand this. All right. I want you guys to try to solve this problem. Pause video and try to solve this problem. Uh-oh, went too far. Hey, listen, guys. I made a decision. What I am going to do is I'm going to go ahead and end the video here, and I'm going to post the practice problems in a separate video. That way I can take my time with the explanations and I can make sure that you understand the steps that we're going through so that, you know, everything is good. I don't want to rush through that because I want to keep the video under a certain time limit. So let's go ahead and end this here and then look for the practice video coming up next. All right, catch you in a second.